We'll move on to the clavicles. So this is kind of an important one because it's a very common mistake that a lot of people make. The clavicles are rotate-only data, and they only have two axes of rotation. They have up and down and forward and back. What they don't have is a twist like this. If you feel your own clavicle, if you move your arm around, you'll see that you get a small amount of rotation in the clavicle as your arm comes forward and back, a broader range of rotation in your clavicle for up and down motion of the arm, but you absolutely have no twist in it at all. It's because you've got the bone joins at the shoulder like this and then spreads back into the neck. So you want to avoid any, in this case, it's X rotate for box person on your clavicles and only have up, down, forward, back. So your humerus has all three axes of rotation, up, down, forward, back, and twist. You want to make sure that you do not animate the translates on your humerus. You can see if you rotate your own shoulder that that's exactly how your own shoulder works. All three. You've got twist, you got up and down, forward and back. It's a little different with your forearm though. Your forearm has only 1 degree of rotation. And in the case of box person, that is all in rotate Z. So we're going to basically see no keyframes on rotate Y, rotate X, translate Z, translate Y, translate X at any point in time for animating. All right. Now onto the wrist. The wrist has 3 degrees of rotation, but if you look at your own wrist, you can see you have quite a fair amount of twist. You can tilt the hand a fair way, but not to a complete 90-degree angle towards your, with your little finger down. And if you go back the other way with your thumb, you've got very little rotation at all in that side, but you've got a big amount this way, and you've got a big amount back and forward. Okay, so that's really important to bear in mind when you're animating. So you don't ever see this without the hand feeling really broken. And you usually don't see the rotation this way go past this point without it feeling really broken. That's pretty important to remember. So onto the metacarpals. These guys really only have 2 axes of rotation. So we have a Y axis and an X axis. We do not want to be seeing twist down here. That is there are times when that will be necessary, but just as a general rule, you want to avoid it. That's true of all of the metacarpals. And then for the fingers, we have 3 axes of rotation. And even though you actually can't twist your fingers, we do need to add a little bit of twist sometimes to get the hand poses that we need. So that's completely fine in the case of 3D animation, is to have some twist on this base joint of your fingers. We'll go into that when we start doing some hand posing later. But on these 2 finger joints, only 1 axis of rotation. So let's say rotate Z, for all of the rest of these. And that is the same for the thumb. So 3 axes of rotation and then only 1 axis of rotation here. Okay, so moving down to the legs, we have feet here with a pole vector for the knees. The way this has been set up is that the knee twist is being driven mostly by the foot position. You're not going to have to really touch these too much, I hope. And the reason why I've done that is in more complicated rigs where you need more flexibility, you do have to manage that knee twist yourself a lot with the pole vectors. It keeps the rig flexible. But for that reason, it's very easy for people to forget that basically the shin here almost always lines up with the top of the foot. So you very rarely have this kind of a situation where the foot's pointing in a completely different direction to the shin. Like there's a little bit of latitude there, but you're never going to see something like like that. It's just feels broken. It's a very easy thing to do, and if you don't know to look for it, you will miss it. The toes for the moment are just a single piece, and we'll really probably just be using 1 axis of rotation for them for now. But I think that just about covers it, really.